working with arc length. So finding, it's kind of like putting an inches feet measurement onto a curved surface, if that makes sense. Those of you that weren't here yesterday, we talked about this thing called a radian, which is kind of like a different way to measure degrees. Okay. 180 degrees is what in radians? 1 pi, yeah. How much is 360? How about 90? Half pi, or pi over 2. How about 45? Pi over 4. How about 30 degrees? Pi over 6. 60 degrees? Look at that. Awesome. Okay. Arc length needs to be done in radians. Okay, when we have our central angle, a angle measure in the middle of our circle or our arc has to be in radians in order to use this formula. Okay, so if we're given degrees, what should we do? Convert it to radians. Okay, that's also something we went over yesterday. Yeah, pretty much all it is this little formula that we have. S is the arc length we're trying to find. All we're doing is taking r, which is our radius, times the center angle. Again, always in radians. Okay? So if I'm looking down here, it says I want to find the length of B. Well, B is this chunk right here, right? So I'm going to have B equals, what's my radius in that circle? 3 inches right here. So I have 3 times. If I'm looking at this chunk B, what's the angle in radians associated with just that chunk? Yeah. If I look at what takes up this arc, it's kind of like this angle right here, right? Does that make sense? Kind of what completes the pi. So my interior angle, or my central angle, is 2 pi over 3. So literally all I have to do is take 3 times 2 pi over 3. What happens with my 3's?
Why are we taking 3 times?
3 is my radius. Because our equation, we have radius times our angle. Okay, what happens with 3's? Cancel. So you need to put in your calculator what 2 times pi is to the nearest 10th. You can just use 3.14 or 6.3. And then let's throw a label on for good measure. Always use the radius measure, inches, and that is literally it. Let's not do that, right? No. If I asked you to find the S, we could do that. So you just gotta be careful of what you're looking for. It could be that, like, you know how this arrow shows just this chunk? There could be a problem where it gave you, like, the whole angle, but you had to take this out. You know what I mean? That wasn't this case. Okay. Other questions? Okay. I think you guys are missing this negative 135 in your notes, so write that in there. Okay. Finding arc length when I have a radius of 7 centimeters and an angle measure of negative 135. So can I take 7 times negative 135? Can I just take 7 times negative 135?
No, you have to convert that to radians.
I have to convert it. Good. Okay. I have degrees. So what do I need to divide by? Degrees. What do I use for degrees? 180. What do I then need to times it by? My pi. Or if you like it, times pi over 180, the exact same thing. I just like to write it that way. Either way works. Okay, So in my formula, I take my angle, which I now have in radians, times by my radius. What's my radius? 7. So put either this one or this one in your calculator. Should get the same thing. 16.5 label. Centimeters. Convert times it by radius. Questions?
How do you know when to use the 360?
Yesterday we talked about when we convert from radians or degrees, we always use pi and 180.
Why is it negative?
Because you can't have a negative arc length. Like when I'm measuring, like, you can't get negative miles in your car. That's a really good question, though. Does that make sense? Other questions? Think about that. Alright, last one. Oh, my picture got kind of cut off. Oh well. It says a weather satellite is in circular orbit, 3,600 kilometers above Earth's surface, and completes one orbit every 4 hours. How far does the satellite travel in 1 hour? Okay, well, in order for you to find arc length, I need what two things in our formula?
Radius.
Radius and radians, our degree measure, right? Let's find degree measure first. That's probably the most complicated thing. So the first thing we're gonna do is find our theta. Find our angle. I only want to know the angle for my 1 hour, right? Okay. Well, if it completes one orbit is around, right? All the way around. So 360 is how much in radians? 2 pi. Okay, so I'm going 2 pi in how many hours? In 4 hours. I want to know how much I get in 1 hour. So what do I have to do? By? Divided by what? Take my 2 pi and divide it by 4. Okay, because I only want to know how much I go in 1 hour. I know I go 2 pi in 4 hours, so split that up into 4 parts. How much do I travel? How many degrees? How many radians in 1 hour? Pi over 2. Right? So my degree is pi over 2. Thinking about in our head, we're going 90 degrees, which makes sense, right? 90 degrees, there's 4 of them in 360. Yeah, he thinks so.
When you put it in your calculator, you put in 2 times pi divided by 4.
Or you could just take 2 divided by 4, which is half, right? Yeah, because we kind of want to leave pi for now. Okay, the other thing we said we gotta find is our radius. Using our handy little picture. How much is the center of my Earth to the crust of my Earth? Is that the right word? I think so. It's been a long time since I took science. What's the radius of just Earth?
6,400.
6,400. Okay. I have to add on the space between the crust of the Earth and the distance to my satellite, right? Which is how much?
10,400. Yeah.
Plus 36.
This is my 64 plus 3,600, which gives me a total of 10,000. No? Yes, no, maybe so.
So the radius is 10,000.
Okay. What do I do with my radius and my theta, my pi over 2? I gotta take 10,000 times pi over 2 and my calculator. And what do we get?
Yeah.
15,700 and would you say 7? 8. Okay. Arc length, all I need is radius and your center angle. That's it. Wow. Questions? How we feel? Good? Okay. We got another book assignment today, but the good news is